Hi folks, let me help you with a little harmonic motion graphing. So today we're going to look at how to make a graph of a pendulum's harmonic motion. You'll notice out here in Moodle I have this assignment described where it talks about using this video to observe a pendulum in harmonic motion. So this is a video I've created, and it's a pendulum going back and forth, and it takes about 2 seconds for one complete cycle. When you'll play the video, you'll notice the pendulum just swings back and forth 10 times in the video. You can also read on the screen, if you look real closely, the angle that the pendulum swings to. On the right, notice it's positive. On the left, notice it's negative. And the idea is that those numbers represent the amplitude of the pendulum, that is how far it swings. So opening up that video and playing it is great. If you want to open it in YouTube, there's a link there as well. But the idea is that when you have that video, then we can open the assignment and use that video to make a graph. So here's what the graph looks like in the assignment in Google Classroom. And what I want you to think about is this. I'm actually going to turn the graph sideways for a minute just to help you visualize what's going on. Think about this graph as simply a record of where that pendulum is while it swings back and forth. So if you imagine that our pendulum hangs straight down in the middle, it might be here. But some of the time that pendulum is going to swing over to one side and it'll be over here. And other parts of the time the pendulum will swing over to the other side and it'll be over here. And that location is what we call amplitude. Again, on the video you notice one side has a positive sign and one side has a negative sign, which matches up to on the graph where you see positive numbers over on the one side and you see negative numbers on the other side. So the idea is on the graph we're going to represent where it's located as time goes on. So the x-axis of your graph is time, and we start with 0 seconds, and the goal is every time it swings back and forth it takes 2 seconds. So you might want to get that labeled on your graph. You'll want to think about the spacing, but maybe 2 seconds occurs every 2 boxes for a second might work. So if we do this, let's say if you look at the video at the beginning, and let's just say, for example, the pendulum starts out here at 17 degrees. So at time 0, I put a dot at 17. And a little while later, I know by the time it's all the way back through one full cycle, 2 seconds later, it's going to be back to whatever number it's at again. And you can check that from the video. Halfway through the time at 1 second, it's down here at negative something or other. And again, we want to check the video and see how far it goes. And then in the middle, it's at roughly 0 in both ways. So in other words, we're going to make a picture that describes how the pendulum is traveling back and forth, which becomes our graph. Now my graph isn't super neat. I'm trying to do a quick job here to show you what it looks like. But as the pendulum continues to swing back and forth, we continue to have this graph taking shape. Now if I turn this back sideways again, you can think about what we're going to end up with as a graph really just represents the motion of this whole system at one time. So I'll turn it back sideways and we'll look at what it ends up looking like. And the harmonic motion graph you end up getting might seem kind of familiar if you think to our work on generators. You might notice this looks something like the graph we got from the ripcord generator as well. But the idea is now we can create this graph, and by the time we get all the way through the motion, you'll probably be up here to around 20 seconds, because of course it's 10 cycles at 2 seconds each. And this motion will continue, and you can work this out real neatly with the numbers, but it'll continue in this up and down harmonic motion pattern all the way through. And again, to know exactly how far to go for each swing, go ahead and play the video and watch it and see how far over and back it comes each time, or at least get it as close as you can estimate. And that is the goal. Again, what we're creating here is a graph of harmonic motion, and it's getting us a way to make a graphical picture of that back and forth motion. Thanks.